Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello students, welcome to this session. In the last session we have started with the geometry design basics, and we have seen the design speed, and we have started with the friction, and frictional force is nothing but simply F is equal to small f into W, that is coefficient of friction into self weight of the vehicle for plain roads obviously. And there are two types of frictions, coefficient of frictions basically, coefficient of longitudinal friction and coefficient of lateral friction. Coefficient of longitudinal friction value varies from 0.35 to 0.4, whereas coefficient of lateral friction is 0.15. And friction is required for stopping the vehicles after the application of brakes and to change the direction, means at the curves you require friction, right? Now, this friction has got some effects of friction. This friction has two major implications over the vehicles. If the friction is more, it may lead to skidding of the vehicles. And if the friction is lesser, it will lead to slipping of the vehicles. So the two major criteria here is skidding and slipping. Okay? And to understand the skidding and slipping, let us consider an example here. Okay? You're traveling in a car with some speed, and you need to travel from A to B here. Okay, so this A to B, this distance from A to B is always fixed in this path, right or not? This is always constant, right? So as you are traveling in this direction, means you are traveling in this way, right? So what can I call this AB as? This AB is called as longitudinal distance, right? Because your vehicle is traveling in the longitudinal direction of the road. So this AB is always constant, and I call this as longitudinal distance. Okay, longitudinal distance. Now I have three cases here, case 1, case 2 and case 3. I have three cases here. Now in the first case, what happens is your vehicle is traveling from here to here, from A to B without application of brakes, and the first case is a perfect case with no problem at all. There are no problems at all, right? So you have not even applied any brake and your road is perfect, road is smooth. And to travel from A to B, what happens here? Your wheel will rotate, right? Your wheel should rotate. So with this rotation only, your vehicle will be moving. With this rotation only, your vehicle will be traveling from A to B. Now, once your wheel rotates one distance, or once your wheel rotates one circle, the distance moved by that vehicle will be equal to, for example, your vehicle has moved from here to here. That means it has taken one rotation. So one rotation is nothing but circumference, that is 2 pi r. So if this vehicle has made one rotation, then your vehicle moves in the longitudinal direction also, right? And the distance moved in the longitudinal direction will be obviously 2 pi r, because this movement is same as this movement, right? So in the first case, that is in the perfect case, that is having no problems at all, to travel from A to B, your vehicle need to make some rotations. So as you're covering this distance, by making some rotations, I can also call it as circumferential distance. Circumferential distance. Right? Because your vehicle wheel is rotating. One wheel's rotation is nothing but one circumference, that is 2 pi r. So I call this as also as circumferential distance. Now the relation in the first case between circumferential distance, CD shortcut, and LD shortcut. Okay. So what would be the relation in the first case, that is perfect case? So as you have not applied any brake and as your road is smooth and good, your vehicle travels smoothly with no problems at all. So the relation between longitudinal distance and circumferential distance will be same. They both are equal. That is the relation, right? So in the perfect case, the longitudinal distance will be same as the circumferential distance, right? Now, come to the second case, that is skidding case. Skidding is my second case, okay? Skidding case. First question, when does the vehicle skid? When will it skid? As simple as it is. Most of us have experienced this when you're traveling on a two-wheeler, especially four-wheeler also you can experience it. Your vehicle will be skidding if you apply sudden brake, right or not? So your vehicle will be skidding due to sudden application of brakes. And what happens if you apply sudden brake? What kind of changes will be there in your vehicle or in your two-wheeler or a four-wheeler, whatever it is? So if you apply sudden brake, the condition of the vehicle will be changing and we call it as wheels locked condition. So if you apply sudden brake, what happens is the wheels get locked. Means your wheel will not rotate, but your vehicle will move on. That is what skidding is. Wheels locked condition. Wheels locked conditions. As you applied sudden brake, brake means you should stop your vehicle. So you have applied a sudden brake. So the wheels get locked, right? So for example, in the second case, you're traveling in the same car now. After traveling some distance, say after coming to point C, you have applied a sudden brake. And at this particular point of time, you have applied a sudden brake. So from here onwards, the vehicle is moving, but the wheels are not rotating because wheels get locked. So at here, you applied sudden brake, but your vehicle will move. Wheels won't move, but your vehicle moves. So your vehicle moved here and it got stopped. So your final velocity is 0, obviously, right? So from here to here, your vehicle has been moved and it has been stopped. So now just tell me what would be the relation between longitudinal distance and circumferential distance. Compare it. Think. That is what they ask in most of the exams. When will it lead to skidding and when will it lead to slipping of the vehicle? A very frequently asked 1 mark bit in many of the government exams, including IES. Yeah, think. So if you observe here, what I said, from here to here, it was moving normally. I have applied sudden brake. So the rotation stopped. The vehicle skidded, reached it, and applied and stop the vehicle, right? So what is happening from here to here? Your vehicle has rotated as usually. So this distance is nothing but circumferential distance now. But in the longitudinal direction, your vehicle started from A and it reached point B. So this is your longitudinal distance traveled by the vehicle, and this is the circumferential distance, which is more. You can see it and tell, right? So when will it lead to skidding of the vehicle? The second case is if the longitudinal distance traveled by the vehicle is more than the circumferential distance made by the wheels, it leads to skidding of the vehicles, right? If the longitudinal distance traveled by the vehicle is more than the circumferential distance made by the wheel, then it will lead to skidding of the vehicle. That is the second statement, second case. Third case is slipping. Will be generally slipping if there is a water or oil, right? The same way, slipping will happen due to existence of oil or water or even sand on the surface, right? Any of these three materials will lead to slipping of the vehicles. Means slipping is due to less friction. It will decrease the friction value, and as the friction gets decreased, your wheel will rotate more faster rate than a normal rate. So to travel the same distance AB, now your wheel will make more number of rotations than the standard number of rotations required in the perfect case. So as your wheel is making more number of rotations, so your circumferential distance will be more than longitudinal distance. So if the circumferential distance made by the wheel is more than the longitudinal distance moved by the vehicle, it will lead to slipping of the vehicle. So by comparing these two statements, by comparing these two values, you can say whether it is leading to a skidding or it is leading to slipping of the vehicles. So you can write it down in 1 minute, I guess. Come on. I hope you're done with the writing part. So we have covered the second geometrical element, that is friction, its effects, types of friction, right? So the next geometrical element is undulations or unevenness. Or unevenness. Does this term has anywhere related with the comfort of the road user? Yes. Undulations or unevenness is the measure of comfort of road user. It is the measure of comfort of the road user. As the undulations increases or unevenness increases, your comfort level decreases, obviously, right? So you can measure the comfort of a particular road by measuring its unevenness, undulations. And if there are undulations on the road, firstly, the comfort level decreases. In addition to the comfort level, there are many other disadvantages, like say vehicle operating cost increases, right or not? Means more undulations means more application of brakes. If more applications of brakes are there, your brakes get damaged, your brake oil gets finished, your bumper gets damaged, so you need to frequently do the maintenance of your vehicle, which is costly. So your vehicle operating cost increases, your speed decreases, so your travel time is going to be increased because of lesser speeds, and finally it may even lead to the accidents. So that is the disadvantages for the unevenness, and this unevenness or undulations can be measured with the help of an instrument called as bump indicator or roughometer. A very important 1 mark bit again, bump indicator or roughometer. Undulation or unevenness can be measured with the help of an instrument called as bump indicator or roughometer. And this unevenness, what you measure, is expressed in terms of unevenness index. UY. So, and it is expressed in terms of centimeters. Undulations are generally small in number, right? Very lesser in sizes. So it is expressed in centimeters per kilometer length. For example, let us consider a kilometer span of road. Okay, this is 1 kilometer of road for which you are going to check the unevenness or the comfort levels. And generally, this bump indicator or roughometer is suitable for roads which are having lane discipline. In India, we have mixed traffic condition, whereas in US, in UK, they have lane discipline. What is lane discipline and what is mixed traffic? If a lane is meant for two-wheelers, only two-wheelers will be traveling. Similarly, if a lane is meant for cars, only cars will be moving. And if a lane is meant for buses, only buses will be moving on that lane. That is how lane discipline is. That is what lane discipline is. So one vehicle will be traveling in that particular lane only. It won't be traveling in the middle of two lanes, or it won't occupy the two lanes at a time. It will be in the one lane itself. That is what a lane discipline is. But Indian traffic is a mixed traffic. So for the same traffic, number of vehicles will be moving, number of different categories of vehicles will be moving on the same lane. So this bump indicator or rougher meter is applicable for lane discipline. It can't be adopted for mixed traffic conditions. Now what is this bump indicator? It is nothing but a fifth wheel. For example, if I've given an option to you, this is a lane disciplined road. This is a lane disciplined road. And if I ask you to travel on this particular road, which part of the road will you try to occupy? First part or second part or third part? Where you will travel on this road? Only you must travel, lane discipline. So one vehicle at a time. So which part you are going to occupy? Obviously, you are going to occupy the center part of the road. So all the vehicles will try to move along the center path of the road. Now that's fine, but after some number of repetitions, after some number of vehicles which are traveling in this route, due to that number of repetitions, your road gets damaged. Basically, your road gets damaged along the center path of the road because that is the path which is moved, which is traced by most of the vehicles. So what I do is I take my vehicle, I take my car, and I attach a bump indicator to my vehicle. This is the bump indicator. That is a very simple device which will measure the unevennesses in this 1 kilometer span. So I'll be starting my car here and I'll be ending my journey here. And this bump indicator will measure the unevenness. For example, if this is how the road is, right? So this bump indicator will tell what is the rise in the pavement, how much is the rise. Similarly, it will tell what is the fall of the pavement. Similarly, it will tell the rise. Similarly, it will tell the fall, and so on. So on. So what is my unevenness index? Finally, sigma rise plus sigma fall. Sigma rise plus sigma fall, right? But that is the total unevenness index. And as I said, that unevenness index is measured in terms of centimeters per kilometer. So this much is the unevenness. For how much length? That is also matter, right? Is it for 1 meter? Is it for 100 meters? Is it for 100 kilometers? You don't know. So what I do is I divide it with length of the road. So generally this variation in the numerator will be very much lesser. So it is in centimeters, and you will be traveling for longer length. So it is kilometer. So that is how you calculate the unevenness index. That is sigma rise plus sigma fall by length of the road, unevenness index. Now once you got this unevenness index, you can say whether your road is operating good or not. So for example, if the unevenness index is less than 150 centimeter per kilometer, that means your road condition is good. And if it is less than 250 centimeter per kilometer, the road condition is said to be satisfactory. And if it is more than 320 centimeters per kilometer, the road condition is unsatisfactory. So that is how you say the comfort of the particular road, whether it is operating good or not. You can say by calculating the unevenness index and by comparing that value with this limits, right? So please note down this. So I hope you have done with this writing part. And that's about the undulations or unevenness. The next geometrical element what we are going to see and discuss is drainage. Drainage. So I hope everybody has seen this movie called Bahubali, right? Pravas is the hero and Rana is the villain, right? And Pravas is named as Bahubali and Rana is called as Ballal Deva, right? And what is the relation between Bahubali and Ballal Deva? Yeah, brothers, and they are the enemies, right? So if water is treated as Ballal Deva, then road is our Bahubali. Means they two are enemies in our roads. So if road and water exist, if road and water together are there, then it will be a great damage, right? So what is drainage? Drainage is nothing but obviously process of removing water from the pavements, water from the road surface, right? And to remove that water, to remove water from the surface, what we provide? Very simple, easy. We provide Kamba, which is also called as simply cross slope. Cross slope, right? It is the slope which is provided in the lateral direction. So if this is our road, if water comes, if rainfall happens, the water will be stagnated here itself. But instead of me providing road like this, what I do is I provide a road like this. I provide a slope. So this is the slope which I provide in the lateral direction. So if I provide my road in this way, if water comes due to the slope, it falls. It goes away automatically through gravity, right? So camber or cross slope, it is nothing but a slope which is provided in the lateral direction. In the lateral direction. Now, there are two main factors here. How much slope should I provide? What are the factors which regulate my slope value? So should I provide my road like this or much higher value? So what is the value which is defining my road slope or my camber? Obviously, common sense, water, rainfall. If the rainfall is more, the slope should be more, right? If the rainfall is lesser, I can provide less slope. If the rainfall is more, I should provide more road so that water goes quickly. And the second major element is type of surface. And we have different surfaces of pavements, right? Like bituminous surface, concrete surface, water-bound macadam, that is gravel roads, and earthen surface. These are the four types of surfaces that we generally have in regard with the roadways. Now, which is the most superior one, most superior surface? Obviously, it is bituminous surface or a cement concrete surface. It is the highest and strongest one. And the least strengthiest pavement is with the earthen road. Now, how you should vary the camber for this type of surface? Superior the quality, flatter is the camber. That's the previous gate 1 mark question of asked in gate. Superior the quality, dash the camber, flatter the camber means, for example, if you construct a if you construct an earthen road, so the quality of earthen road is lesser. So if you provide less slope, what happens? The water which falls will slowly travel. It will travel, but it will travel slowly. And as this is a earthen surface, as this is an earthen road, as it is traveling slowly, the contact time is more and more water will be percolated below surfaces. But for the same earthen road, now I increase my slope. Now what happens? Water comes, water falls and drains off quickly, moves quickly, right? So the contact time will be lesser. So as the quality of the surface decreases, you should decrease the contact time by increasing the camber, by increasing the cross slope, so that less amount of water will be percolated, right? So these are the two major factors which are influencing the camber or cross slope. So based on these two factors itself, IRC has given a table like type of surface and rainfall. And rainfall can be less rainfall or it can be heavy rainfall. And there are four types of surface: bituminous or cement concrete surface. Second one is thin bituminous or thin cement concrete surface. Third one is water-bound macadam surface. And fourth one is earthen road, earthen surface, right? So there are four types of surfaces, and this table is to be remembered because for solving problems related to the camber or related to this topic, you need to know these values. So you need to remember this table, these values mentioned as per IRC. But of course, it is very easy to remember. And as I said, camber is nothing but a cross slope. Cross slope can be represented, slope can be represented in three formats as I discussed already in the last class, last session. So here I am using the percentage formats first. It is very easy to remember. It is 1.7%. Now, for the same bituminous or cement concrete road, now the rainfall is more. So the camber should be more. So it is 2%. So if the rainfall is less for a bituminous road, you go for 1.7%. If the rainfall is more, you go for 2% of camber. Now, the second one is thin bituminous surface or a thin cement concrete, means the top surface is of small thickness, lesser thickness, so the quality is lesser compared to the previous one, so the camber should obviously increase. So 2% and 2.5%. The same value, 2.5%, same, easy to remember, and 3%. Same, easy to remember, 3% and 4%. Now, for remembering, you can use these values, but for solving problems, as I said, you need to convert these percentages into 1 in n formats. So you need to know how to convert them from percentage to 1 in n as well as from 1 in n to percentage formats. See, 1.7%. So I want in 1 in n format. 1 in n is nothing but 1 by n into 100. That is how we convert into percentage, right? So 100 by n is equal to 1.7. Percentage is nothing but 1 by n to 100. So I have given it as 1.7%. 1.7% is equal to 100 by 1 in n. So from this, n is equal to 100 by 1.7, approximately 57.77. Approximately we take it as 60. So 1.7% is nothing but 1 in 60. 100 by 1.7, 57 point something. So 1 in 60. Similarly, 2% is 100 by 2, 1 in 50. The same 2%, 1 in 50. 100 by 2.5, 1 in 40. So 1 in 40. 100 by 3, 1 in 33. So it is 1 in 33. 100 by 4 is 25. So 1 in 25. So you need percentage. If you know the percentage, you can convert into 1 in n format easily, of course. And this table is to be remembered. Now, this is how the camber values will be obtained from the table. But we have different types of cambers also. Based on the shape, the cambers can be classified into straight line camber, parabolic camber, and combined or mixed camber. Combined or mixed camber, right? So based on the shape, I'm going to write it now. So this is a straight line camber. This is a parabolic camber, and this is a combined or mixed camber. right? Now in all these cases, let us say the width of the road is W. Let us say the width of the road is W. Combined or mixed camber is a combination of straight, parabolic shape, and straight paths. And let us say the camber is 1 in n. One in n. And who will give you that n value, ma? From where will you get those n values? Yes, that n values is obtained from this table. 1 in n. N value is 60. N value is 50. N value is 33. N value is 25. Right? So that is how from this table you will get the values of n. Now, this is the point of highest elevation. Generally, highest point is called as crown. Crown. And crown will be at a distance of W by 2. Similarly, W by 2. Crown will be at a distance of W by 2. Now, the height of crown is equal to W by 2n in case of a straight line camber. How you got it? I have said camber is 1 in n and it is a straight line. It is a straight line. So if there is a straight line in mathematics, you can go for interpolation. And how you will interpolate it? 1 in n means n horizontal is to 1 vertical. Means if you travel n meters horizontally, the vertical rise is 1 meter. Now, at what distance you want the height of crown? At what distance is the height of crown exist? At a distance of W by 2. So if this is say Y, so at what distance you have the crown? Y. At a distance of W by 2. So simple cross multiplication. W by 2 into 1 is equal to n into y. From this, y is equal to W by 2n. So height of crown is W by 2n, right? And next one is a parabolic camber. So equation for parabola is y is equal to ax square. Y is equal to ax square. Now let us say this is my origin, and this is my x direction, and this is my y direction. When x is equal to 0, y is equal to 0, right? Origin. When x is equal to 0, y is equal to 0. When x is equal to W by 2, y is equal to W by 2n. In the previous case, we have seen height of crown is W by 2n, right? So same height of crown will be W by 2n only. Height of crown will be W by 2n only, right? So when x is equal to W by 2, y is equal to W by 2n. So using this equation now, y is equal to x square. Now y is W by 2n is equal to a into x square is W square by 4. So 1 W and 1 W gets cancelled, and this 2 and this 2 gets cancelled. So a is equal to 2 by nw. From this, y is equal to ax square, which is equal to 2x square by nw. So the equation for parabolic camber is 2x square by nw. The equation for parabolic camber is 2x square by nw, right? Y is equal to 2x square by nw is the equation for parabolic camber. Now the question is, when should you go for a straight line camber and when should you go for a straight line camber and when should you go for a combined or mixed camber? That is very simple. Or the same question I will ask in this fashion. Which shape is suitable for fast moving vehicles and which shape is suitable for slow moving vehicles? Come on, think. Think. Two vehicles are there, fast moving vehicles and slow moving vehicles. Which shape is convenient for which type of vehicles? Yeah. Straight line camber is suitable for slow moving vehicles. Slow moving vehicles. Why? Fast moving vehicles generally travel in the center part of the region because they will be overtaking. They will be overtaking the slow moving vehicles. So if you observe these shapes properly, your road is steeper at the edges and it is flatter at the crown for a parabolic camber. So fast moving vehicles prefer parabolic shape because fast moving vehicles generally travel in the center part of the road, and in this parabolic camber shape it is flatter at the center. Now if you see this straight line camber, this is the center part of the road, and for example if I want to overtake a slow moving vehicle, so if I am traveling this way, then I get down in this direction, I overtake the vehicle, again I come back here. So you are getting down from the crown and again you are climbing the crown here. So there is a change of crown movement here. So there will be a small jerk feeling because of this unevenness if you want to overtake in this fashion. So obviously this is suitable for slow moving vehicles, this is suitable for fast moving vehicles. Then I combine these two things in the combined or mixed camber. So straight line part is used by slow moving vehicles, and parabolic fast moving vehicles will be occupying the center part. So parabolic part will be used by fast moving vehicles. And generally by default a cement concrete pavement is constructed with the straight line camber only. So by default, if I say cement concrete pavement, that means I'm talking about straight line camber only, right? So this is how we provide drainage, by providing camber or cross slope, and these are the values and these are the shapes, and this is the equation, that is height of crown is W by 2n and the parabolic equation is y is equal to 2x square by nw. So we can note it down now.